what we do is we get a little tilt to the pleasure side and we get the release of dopamine in our brain's reward pathway, which is this evolutionarily, phylogenetically conserved, very, very old part of the brain that's been unchanged in our brains for just millennia and is also identical in other species, all the way down to the lizard, which is why it's sometimes called the lizard brain. Our evolution meant that we've piled a whole bunch of other layers on top, but that part is exactly the same as it's always been. And it's the part that gets us, again, to approach pleasure and avoid pain. But here's really the key. The way that the brain restores a level balance or homeostasis after this deviation to the pleasure side is to not just bring it level again, but tilt it an equal and opposite amount to the side of pain. And that's called the opponent process reaction. And I sort of think of that as these little gremlins that represent neuroadaptation, hopping on the pain side of the balance, but they like it on the balance, so they stay on until it's tipped an equal and opposite amount. That's that moment of wanting just one more video game, another beer, another piece of chocolate. Now, if we wait a little bit, because it's a powerful physiologic drive to reach for more. If we wait, the gremlins hop off, that feeling passes, and homeostasis is restored. And we want homeostasis to be restored. It's really important because it's fundamental to the resilience of this system. Because when the system is at baseline homeostasis, it's sensitive, right? It senses new pleasures. It's aware of potential dangers and painful things, so we know to avoid